Okay, so let's start talking about SQL. SQL is an acronym that stands for Structured Query Language, or depending on who you talk to, they might say it stands for Standard Query Language. Anyway, SQL is the command language behind almost all database operations. We're talking about SQL in the context of queries, but SQL can also be used to create databases, to create tables, to insert data into tables, to update tables, and delete tables. So there are a lot of things you can do with SQL other than just retrieving data from a database, but we are going to look at retrieval in this particular session. The first thing to know about constructing SQL queries is it's not like doing a query for Google or like an article database that you might use in ResearchPort. The product of any SQL query is going to be a table. So it turns out that the logic of constructing your SQL query involves using the SQL language to describe the characteristics of the output table that you want to get in response to your query. So you're saying, if I'm going to see my results as a table, what do I want that table to look like? Which columns should be in that table? What should the names of those columns be? And how should the rows be ordered in that table? And under what conditions do I want data to appear in those rows? So the two most primary components of the select command are select and from. Notice this convention I use where the actual SQL commands are in all caps, then arguments to the command are in lowercase or mixed case. This is just normal convention for formatting your SQL statements, and I would like you to try to follow it. So we open a SQL statement by filling out the select command. In the select command, you will list, from left to right in the order that you want, the names of the columns you want in your output table. Remember, the output of any SQL query is a table, so the select statement is naming what the columns of that table should be. Columns will appear in the output table in the order you put them here. Separate multiple columns with a comma, but don't put a comma after the last column name. Once you've listed the components of the select statement, you fill out the from statement, which is nice and easy. Just put in this statement, separated by commas, the names of the tables that contain the columns you selected in the select statement. Let's take a look at a simple select from statement. So this select statement looks at the movie database and selects title and release year from the movie table. In case you haven't pulled it up yet, the movie database is a PDF file saved in the Canvas course modules for session 7. We're also implementing the use of aliases here, which allows you to customize the names of columns in your output table. It's a pretty easy syntax to pick up, but if you have any trouble with it, this is covered in the Fahili reading for this session. So this statement tells the database system to go to the movie table and get the title column and the release year column and display the data that goes into those columns. We alias the title column so that our input table has the column heading movie instead of the column heading title, which was the column heading that was used in the database. So if you don't use an alias, then the output table is just going to have the same column headings as the original table in the database had. So that is your most basic SQL statement. Adding an order by clause to the query. Order by, just like it sounds, lets you specify how the table should be organized. If you don't put an order by statement, there's no meaningful order to the rows in the table. They won't be alphabetized or sequenced in any way, and the rows will be in random order. So in this query, we want to see a list of movies ordered by release year. The default is ascending order. And just for kicks, I said to order by title in descending order. Since title is the second argument in the order by statement, title will only work into the ordering when there are multiple movies within the same year, since year is the primary order mechanism. So select from and order. Most of our attention will be on understanding the where clause. The where clause of your SQL query is where you can state the conditions under which you want data to be retrieved. First of all, you can use where to filter your results. These are all described in the Fehili reading and illustrated with examples, but briefly, you can filter with Boolean operators like and, or, and not. You can use mathematical comparison operators like equals, does not equal, less than or equal to, greater than, and greater than or equal to. You can also do what's called pattern matching with like. Like is the one that lets you compare alphanumeric strings. So if you wanted to see all of the movies with Keanu Reeves, you could use where name is like Keanu to get all movies with a person whose name includes the character string Keanu. Range filtering is just asking that results be included. It's just asking that rows be included in the results table if they fall within a certain range. So if you want all movies from the 1990s, then you would say where release year between 1990 and 1999. You might want to do null testing if you want to check your database for missing data that should be there. Let's look in a little more depth at the Boolean operators and the where statement. These operate just like Boolean operators that you might be familiar with in bibliographic environments. They can be nested with parentheses if you end up stacking a bunch of them together, sort of like in a mathematical equation. You need to use parentheses to specify order of operations. The same is true if you have complex Boolean queries that combine operators. The not operator is placed before the condition that it negates. So conceptually how the not operator reads is, it is not the case that, so on and so forth. So let's look at that in a query. We could say select title as movie. So this means that our output table would just have one column, and the heading of that column would be movie from the movie table, where it is not the case that the release year equals 2003. So the output of this query would be a one-column table that would be a list of movies that were released in a year other than 2003. Like I said before, the like operator allows the matching of strings and characters. There is a good list of the permutations of like on page 114 of the Fehili chapter about query operations. But basically, like is used for text searching. So our example query here is select name and birth year as born. So we're going to label the birth year column as born from the person table, where name is like Wachowski. And then you'll see that Wachowski is enclosed in percent symbols and then also in quotation marks. Anytime you're using a text string in SQL or an alphanumeric string, it needs to be in quotation marks. But you don't put quotation marks around integers and dates and other data types like that. But if it's a varchar data type, then you have to use quotation marks to use them in a query. What those percent symbols pertain to is sort of a wild card, but it's an indefinite wild card. So any name that includes the letters WACHOWSKI should yield a hit from this search, regardless of what characters come before or after the WACHOWSKI. You could also use, I think, an asterisk for a one character wildcard, which would just mean that only one character could precede or succeed the Wachowski character string. But the percent sign is a more open-ended, any name that includes any words that have that text string embedded within should be in the list. A really important component, this is not a specific command, like or and or not or something like that. Instead, when you do a join, you are just telling the database how to connect the information in your tables and make use of the foreign keys that you use. If you go on to, You'll find out that there are different kinds of join and different commands for expressing joins, but we're going to go with this more straightforward expression just for our purposes in 670. As we've seen in the previous slides and example queries, we can use all sorts of ways to filter the results of output tables so that only rows that match your search criteria appear. After we have expressed those filters, then we use a simple set of equivalence statements connected using the AND operator to specify to the database how the tables in the queries connect to each other. The way you do this is by expressing that the value in a foreign key cell corresponds to a value in a primary key cell. Let's look at the example query on the slide. Select title from movie where location label equals hall closet. So far, so good. We want to see a one-column table that lists the titles of all movies and the hall closet location. What is incomplete about this query is that even though we will only see data from one of the tables, because our output table just has movie titles from the movie table, the query actually contains information that links the movie table, the locations table, which is a controlled vocabulary, and the movie format location table. In the beginning of the where clause, we said that we only want to see movies in the output table whose location label equals hall closet. But the database needs to make a few hops to get from the phrase hall closet to the title of a movie. The join statement tells the database where to hop to get that information. First, we need to hop from the phrase hall closet to a relationship that connects movies with that particular location. Hall closet is a varchar value in the locations table, which is a controlled vocabulary. So, since we've grabbed the hall closet label, we need to connect the corresponding controlled vocabulary primary key with the movie format location table. If you look at page 2 of your movie database for the hall closet location label, you'll see that the corresponding primary key for that location is LO1. So LO1 is a primary key in the location ID column, and it corresponds to a column called location in the movie format location table. It's a foreign key in the second table. So yay, we've gotten from the location label to a table that links locations with movies. Now, we need to follow that connection over to the movie table so that we can find the titles of any movies that have the LO1 location. That's where we get the final line of the query that says movie equals movie ID. In the movie format location table, the column called movie contains foreign keys that correspond to the movie ID primary key column in the movie table. So we say movie equals movie ID to draw the connection from the movie format location table over to the movie table. Then we put a semicolon on it, and then we're done. Take a look at the queries in the query examples sheet in the course module for more examples of where statements. Once you get the hang of it, you'll see that it's just a matter of starting from the tables you mentioned in the filtering portion of your where statement and making sure that you draw every foreign to primary key connection that you need for your query.